Welcome everyone to today's tutorial, and today we are going to be talking about surds. Okay, this is one of the interesting topics in maths that you understand in no time. Before we start, I would like to tell us about this little caption I put here. Jesus loves you because you are the most important person. Yes, why do I have to say that? When you think about the price God gave us for our redemption from sin, sickness, and death, is a priceless gift. That's the blood of Jesus Christ. Because no amount of money was able to purchase us, no amount of commodity was able to buy our freedom. But God, in His mercy, in His rich grace, sent His Son Jesus Christ to die for us. And that tells us how much God loves us, how much Jesus Christ, our Father, loves us, because you are the most important person. You are His masterpiece. You are the crown of His creation. So His love beckons on us every moment of our life to draw close to Him. I believe we are blessed by that. Moving on today's topic, talking about sword. A sword is a radical. Let me emphasize a little on that. A radical is just a root of a number that will result in an irrational number. Let's say this expression I have here, root of a, gave us 4.1397 and keeps on going. So this is an irrational number, because their exact discrete value cannot be determined. Only approximate values can only be calculated or estimated. And like we can get the approximate value of this root of a that tells us this long number can be approximated to 4.13 or 4.1. But numbers like the roots of 25, which will give us just only 5, root of 81, which will give us just 9, all these are exact numbers, and therefore they are not surd. So a surd is basically a number that cannot be expressed in a rational number like this. It will only give us an irrational number. Okay, a radical will not give us a number that is expressed as a ratio of two integers. No, it's only give us a long number. Other examples of irrational numbers are numbers like pi, 3.142, so on and so forth. Alright, I'm going to take us through some rules in surd. The first rule we have in surd is when we have two numbers multiplied under the same square root, let's say a times b, that's equal to those same numbers multiplied in different roots. Root of a times root of b. The second rule in surd is that of division. If I still have a all over b, this is equal to these same numbers, but this time they are going to be divided in separate roots. So this is another law. And then the third law is rationalizing surd expression. B all over the root of a is equal to, rationalization simply means removing the radical, that's removing the root of the denominator. That's what we mean by rationalizing the denominator, when we remove the root in the denominator. And we do that by multiplying the fraction, this surd fraction. We multiply the numerator, that's the up number, and the denominator by the denominator itself. So b times a is b times root a is b root a, and then root a times root a is the same thing as a raised to the power of half, that's root a times a raised to the power of half. So law of indices states that when two bases are the same, we bring them down as one. We bring them into one and add their exponents. These are bases that are the same, and their exponents can also be different or the same. But once we have their base the same, we only add their exponents like this. So I'm going to have 1 plus 1 all over 2. This is equals to a raised to the power of 2 all over 2, which is still equals to a. 2 over 2 is 1, or just a. So root a times root a is a. Then the fourth rule is factoring surds. When we have a root c plus, it can be minus b root c, this is going to be equal to, we'll factor, these are called similar surd. Why? Because their radicals are the same. So this will be a plus, it can be minus b in brackets, then root c. Then the fifth rule or the fifth law is c all over. This is an example. All these letters I'm picking, they are called arbitral terms. They are just chosen to represent any number. Okay, b all over n, b root n rather. So this is a surd, and this time around it talks about rationalization. The difference between this and this is that for us to rationalize this expression, we have to multiply the denominator by the conjugate. We have to multiply the numerator and the denominator by the conjugate of the denominator. The denominator here is a minus b root n. The conjugate of a minus b root n is just a. The only thing that changes is the sign. So the sign will be the opposite. The opposite of minus is plus, b root n. So a minus b root n is equal to its conjugate, and the conjugate is this. Okay, sorry, this is not that they are equal per se, but we are getting it, we are deriving its conjugate from the original expression. So I'm going to multiply the denominator and the numerator by the conjugate here. So it's going to be a plus b root n all over a, the same thing, a plus b root n. All right, this time let me clean this so I can have space. So I'll multiply the denominator to, the numerator to the numerator. C times A is CA plus C times B root n, that's CB root n all over A times A. A times A is A square, minus times plus is minus, B times B is B square, and root n times root n is n. I'm multiplying this the same way we do our normal. Okay, yeah, if I were to go with that normal algebraic multiplication, which we have been learning right from junior high school, a times a, but when you do all those things, you see arrive at this, just because I have to finish up this quickly to save up time. So this is the final result we'll have after finish simplifying everything. So what I just showed you there is rationalizing a surd using its conjugates. All right, let's take the first example. Hope I believe we are clear about this one I said earlier. Just make this work neat a little bit. Just a times a times b root n minus b root n times a, and then this times this. Once you do it, you arrive at this. I just want to make that clear. All right, So my first example is that I'm going to show you how to convert single surds to their basic form. For example, root 200. Okay, first of all, you know how we get our perfect squares. When you multiply all the numbers from 1 to as much as you can in pairs. 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, 100 times 10 times 10 is 100. So if you take each of these numbers and you square them, it gives you back the number used to multiply it in pairs. So square root of 4. Square root of 4 will give you 2. Square root of 1 will give you 1. Square root of 9 will give you 3. Square root of 16 will give you 4. Square root of 25 will give you 5. Square root of 36 will give you 6. So when we want to compute this, we want to change this single surd to the basic form, we just look for two numbers, the factors of 200 that are very high, of which one should be a perfect square. So 10 here is a perfect square, because no, like 100 is a perfect square, sorry, 100 is a perfect square. So I'm going to use 100 times 2. 100 is a perfect square. So 100 and 2, they are all factors of 200. And those are the highest factor. 100 times 200. The next thing according to the multiplication law is that they will be separated into individual roots. They will be separated into individual roots. So the root of 100 is 10, and the root of 2 will not give us an exact value. It will only give us a very long number that will end up in approximation, but for clarity's sake, we'll just leave it in root 2 and then we multiply it. This is the final answer. So simple. Okay. Let me give another example. Still on this. I can wipe this off. So give the next example. So the root of 125. So if I take us down here, you see that two numbers that we can multiply, of which one should be a perfect square, that will give us 125 is 25 times 5. 25 times 5. And those are the highest common factor. 25 times 5. These are the two highest common factors that can divide 1 to 5. So I'm going to separate them in their individual roots. The square root of 25 is 5, and the root of 5 is just still square root of 5, because if you try to compute that, you have a very long number, and we just need it in its basic form. So that's our answer. Okay, now what if you are asked to change a surd that's in its basic form back to its single state? Let me give us an example on that. So example 2, let's have this example 9 root 3. How are we going to change this surd as in its basic form? Basic form simply means we have a a number that is outside the root like this into a single form. So we'll just put these two numbers back into one root and then square the first number. So 9 squares 81. We are just reversing what we did in the first example. 9 squares 81 times this 3. And 81 times 3, put your roots. 81 times 3 is 243. So this is how to change a surd in its basic form to a single state. One more example. If I take the next example, okay, I have 11 root 6. Same thing, I'm going to put these two numbers under the same roots and then square the first one. Don't forget to square the first one. 11 squares 121 times 121 times 6. 121 times 6 is 726. So it's that simple. Now, like I talked about similar surds earlier, so we'll take some examples on similar surds. Okay, so I'm asked to simplify root 45 plus root 125 minus 2 root 80 plus root 20. Alright, this is a very simple example. What we have to do first, we have to change each of those single surds. We have to change them to their basic form, like we did in the first set of examples that was solved. So starting from 45, what are the two numbers that when we multiply them, one should be a perfect square that will give us 45. So the highest common factors of 45 that will be multiplied to give us 45 is, they are 9 times 5. 9 times 5 is 45. Okay. Root, what are the highest common factors of 125? Okay, that when multiplied will give us 125. That's 25 times 5. 25 times 5. These are the highest common factors of 125. That when we multiply them, we have 125. Bring down my minus, bring down my 2. I'm only working on the roots. So what are those two numbers? When I multiply them, I'll have 80, of which one should be a perfect square. That's 16. 16 is a perfect square. 25 is a perfect square. 9 is. So I must have one perfect square. That's 16 times 5, 80. Plus, what about 20? That's 4. 4 times 5. Note, I'm using perfect squares. One of the factor must be a perfect squares. Okay, so the next step I'm going to do is I'm going to separate them into their individual roots so that I can simplify them further. I'm bringing these numbers down. Square root of 16 already to save time. Square root of 16 is, so I'll do 2 times square root of 16 times root 5 plus, let me first of all take it one step at a time. This times, not plus, this times. Make my work look better. So this times root of 5. Right, so I have the square root of 9 is 3. 3 times root 5 is root 5 plus square root of 25. 5 times root 5, now 5 root 5 minus will come down. 2, now this will be 2. I brought my minus down already. So root 16, if you compute root 16 in your calculator, you have 4. So 2 times 4 is 8. 8 times root 5, that's root 5, plus root of 4 is 2, so 2 times root 5 will be 2 root 5. Now, having gotten to this stage, you'll notice that each of these have the same radical. Therefore, they are similar sort. So the next thing I have to do is that I'm going to just factor out the root 5 outside. Then in a bracket, I'll put these numbers in front. So I have 3 plus 5 minus 8 plus 2. So 3 plus 5 is 8. 8 minus 8 is 0. 0 plus 2 is 2. So my final answer is 2 root 5. Okay. So I believe that's an example that is very easy. So I'll quickly solve one more example. I'm gonna wipe this off. I believe we are enjoying this tutorial. Like I said, so this the easiest work that you just have to understand. It involves understanding and knowing your perfect squares, and it also brings to your notice about rational and irrational number. So let me look at an example on multiplication of surds. Alright, so this is 2 root 6 plus 1 brackets times root 3 minus root 2. Okay, like what I was trying to explain earlier, we are going to I hear some people call it FOI. FOI method is multiplying each of these times this same expression times this, then this times this times this. So we'll begin with, okay, let me take that down. Okay. Okay, yeah. So that's it. So we'll begin with multiplying this times this. Okay. So let's begin. To make it easy, I can separate it. I can have this 2 root 6 times everything here. This is one easy way we can solve it. Then minus root 2. And then I will then use this minus 1 precisely to also multiply this expression. So I have root 3 minus root 2. Okay. This 1. So let me multiply. 2 root 6 times root 3, that will be 2 root 6 times root 3, that's root 18. 6 times 3 is 18. We multiplied this root 6 times root 3. We just did 6 times 3, that's 18. then 2 root 6 times minus 2 root times minus root 2. That's let me write it down here so that we won't know what I'm doing. 2 root 6 times minus root 2. So that's going to be 2 minus negative root 2 root 12. So I'll write it here, minus 2 root 12. Sorry for my slanty work. Then minus 1 times root 3 will be minus root 3. Okay, this is not equal to. So minus 1 times minus root 2, minus times minus will be plus. 1 times root 2 is root 2. Okay, so same process we did in the first example. We are going to, each time you are working on surd, try as much as possible to convert each of the single surds to their basic form. Okay, so this and these two that I underlined can be expressed in their basic form, because they why I left 3 and 2, there are no factors of 2 of which one should be a perfect square that when multiplied will give you 2 and 3. They are just simple numbers. So we have 2, what are those factors of 18? 9 times 2, you can see 9 here is a perfect square, minus 2, what are the factors of 12 when multiplied? 4 times 3, 12 minus root 3 plus root 2. So the next step, I'll separate them like this, minus 2 root 4 times root 3, then bring the rest down. Okay, so the square root of 9 is 3. 3 times 2 is 6. 6 times root 2 is root 2. Then the square root of 4 is 2. 2 times 2, I'll bring down this minus. So 2 times 2 is 4. 4 times the root of 3 is 4 root 3 minus root 3 plus root 2. Okay, so I'll pick out my similar surds. Let me wipe this off to have space. So let me pick out my similar surds. My similar surds are those ones that have the same radical. So 6 root 2 plus root 2, and then minus 4 root 3 minus root 3. They are having the same radicals. 4 root 3 minus root 3. So remember, what's in front of this radical is 1. Let me make that clear. This plus. So this is 6 plus 1 is 7. Then we can, it's just like saying 6x plus x is 7x. That's all. That's just a simple operation. Then minus 4 minus 3. You can just bring that same analogy we did. Minus 4x minus x, that's minus 5x. But minus 4 root 3 minus root 3 will be minus 5, because there is a 1 here in front. There's a 1. So minus 4 minus 1 is minus 5 root 3. And this is our final answer. Alright, so if we have any question, any comment at all, you can please drop it down in the comment section. Thank you so much. God bless you and have a wonderful day. Thanks.